Okay, this is 1995 AB2 calculus problem, and it is asking, a particle moves along the y-axis so that its velocity at any time t is greater than or equal to 0 is given by v of t equals t cosine t. At any time t equals 0, the position of the particle is y equals 3. Part A. For what values of t when t is greater than or equal to 0 or less than or equal to 5 is the particle moving upward? So to start off, the particle is going to be moving upward when the velocity is greater than 0, and also when t is greater than or equal to 0, because that's what it gives us in the problem. And so you're going to want to make another little number line using your limits 0 and 5 given in the question, and then you're going to use the critical points, which are found by setting the velocity equal to 0, and you'll find that those points are pi over 2 and 3 pi over 2. And so you're going to put those on your number line, and you're going to find a point between 0 and pi over 2 and plug it into your velocity equation and see if it is a positive or negative number. So if you plug a number in between 0 and pi over 2, you get that your velocity is positive, so it's increasing, and you put a little plus sign. And then you're going to want to find a number between pi over 2 and 3 pi over 2, plug it into the velocity, you get that it's negative, so it's decreasing. And then find a number between 3 pi over 2 and 5, and plug it into the velocity formula, and you get that that number is positive, so you put a plus sign, and it's increasing between those 2 points. Okay, so the question was asking, when is the particle moving upward? It moves upward when t is between 0 and pi over 2, because it's increasing at that point, and when t is greater than 3 pi over 2 and less than or equal to 5. Okay, Part B. Part B is asking to write an expression for the acceleration of the particle in terms of t. The acceleration equals the derivative of the velocity, so here's our velocity formula. And then to find the derivative of that, you use the product rule, so you'll get a of t equals t times negative sine t plus cosine t, and then when you combine that, you get this. Part C is asking to write an expression for the position of y of t of the particle. And so to find the position, you're going to want to do the antiderivative of the velocity, and the only way you can do that is through integration by parts, which is this formula. And so using this formula, you'll see that u is going to be t, our velocity, in our velocity equation, and dv is going to be cosine of t. So then to find du, you just do the derivative of u, which is dt, and find the antiderivative of dv, which is v equals sine of t. And then you're going to plug that into the equation, so you get y of t equals t sine t minus the integral of sine t plus dt, or sine t dt, and that equals t sine t plus cosine t plus c. So once you have that plus c, you're going to need to find the c and plug it back into the original equation. So if we use the point given in the original question, it tells us that at t equals 0, the particle is y equals 3, so we're going to use that point. So you have y of 0 equals 3, so then you're going to plug that in and you'll get that c equals 2. So take the position formula that we just found and just plug c into that equation, and that's your answer. So for part D, it's asking us, for when t is greater than 0, find the position of the particle the first time the velocity of the particle is 0. So earlier in part A, we found that The first time the velocity equals 0 is at the critical point pi over 2. So we're going to use that point in this equation. And so we referred to the critical points from part A and saw that the velocity equals 0 at pi over 2. So we'll take our position formula that we just found in part C and just plug pi over 2 into that formula, and you get approximately 3.571. There we go. And round that to 3 decimal places because that's what they ask you to do on the AP exam.